Take a look at some SAT style questions relating to linear equations. By the way, for these questions, I'm going to solve them first algebraically and then using Desmos if possible. So let's start with this one. It says if 4x minus 7 equals 13, what is the value of 12x plus 5? So the most straightforward way to solve this algebraically is to solve for x using this first equation and then plug that into the second equation. So that's what we're going to do. We have 4x minus 7 equals 13. We want to find 12x plus 5. So what I'll do is I'll solve this by adding 7 to both sides first, and I get 4x is equal to 20. And then I'll divide both sides by 4, right? Because I want to get rid of this 4. So when I do that, I have x is equal to 5. Now all I need to do is plug that into here. And you'll notice that I get 12 times 5 plus 5. 12 times 5 is 60, so I get 60 plus 5, which is 65, right? So 12x plus 5 is equal to 65. All right, well, that was algebraically. Now let's try solving it using Desmos. So I'm going to plug in, the way that you can solve this using Desmos is you see this equation 4x minus 7 equals 13. All we need to do is plug that equation into Desmos. You can plug an equation into Desmos and you'll see that what happens is we get this line going through this vertical line, right? And the reason why we're getting this vertical line is because if you were to solve this equation, if you were to simplify it, like we did before, you would get x equals 5. And the thing is that x equals 5 is a vertical line, right? Where x is just always equal to 5 no matter what y is equal to, right? So that's why we end up getting this vertical line. And you'll see that when you plug in an equation like this into Desmos, Desmos will automatically solve it for you, and then it will plot a vertical line at the x value that is the solution, right? So we end up getting x is equal to 5 here, right? We don't need to think about the y value. We just need to focus that x is equal to 5. So that's going to be our answer. Well, not quite. Close, right? We're not looking for x here. We're looking for 12x plus 5. So once we find that x is equal to 5, what we can do is, I'll just plug in 5 for x in 12x plus 5, right? So I have 12x plus 5, and I'll just replace this x with 5, and Desmos will evaluate this, and it'll tell me that x is equal to 65. So that's how we can solve that using Desmos. Okay, now let's look at this one. If 6x plus 18 is equal to 30, what is the value of x plus 3? Okay, so we're going to solve this. It's like a similar problem to last time, but one thing I'm going to do differently here is, we have 6x plus 18 equals 30, and I want to find x plus 3. Okay, so before we just, solve this equation for x and then we plug that into here, right? And there's nothing wrong with that. But in this case, there is a faster method. If you notice that all three of these terms have a common factor of 6, we can just divide all of them by 6. And, you might be wondering, what's the point of that? Well, what happens is, when you divide all the terms by 6, you end up with, 6x divided by 6 is just x, right? Because 6 divided by 6 is 1. 18 divided by 6 is 3. And 30 divided by 6 is 5. So we pretty much one-shot that problem, using one operation, right? Again, we could have solved this the long way by solving this entire equation for x and then plugging that into x plus 3. But if you're able to pick up on these patterns, if you're able to just pick up on the fact that there are common factors here, and think about what happens if I divide the entire equation by a common factor. It won't always work. Like in this problem, we couldn't use that trick, right? Because they didn't really have a common factor. But sometimes there are problems where you can get lucky, and as the College Board will give you a trick or an easier way to solve it. So just keep that in mind. So we get that x plus 3 is equal to 5, and again, we can solve it using Desmos as well. So we got that x plus 3 is equal to 5. And the Desmos solution here is, again, you first just plot 6x plus 18 is equal to 30, and you end up with x is equal to 2, right? And then you can do, if you want to find x plus 3, I mean, you could use Desmos for that, but you could also just say that 2 plus 3 is equal to 5, right? So that's going to be my answer. Okay, let's do this last one. This one is slightly harder, but it's still not going to be too bad. Again, we'll solve it algebraically, and then we'll solve it using Desmos. So if 4 times 2x minus 6 minus 9 equals 3 times x minus 3 plus 12, x is a solution to the equation, what is the value of x minus 3? Okay, so I'm actually going to show you how to solve this using two different methods algebraically again. So again, the first method is the long way. So let me just write down our problem. So what I can do is I can just solve this for x, right? And that's gonna take a while, but we can do it that way. So I'll distribute this 4 into the parentheses. I get 8x minus 24 minus 9 equals, and then I'll distribute the 3 into the parentheses. I get 3x minus 9 plus 12. Then I'm going to combine like terms, which just means I'm going to combine negative 24 minus 9. I can, replace that with negative 33, right? And on the right side, negative 9 plus 12, that's just plus 3, right? Now I can move all my x terms to one side, so I'll subtract both sides by 3x. And I end up with 5x minus 33 equals 3. Now I'll add both sides, I'll add 33 to both sides to cancel out this negative 33, and I get 5x equals 36. Then divide both sides by 5, and I get x equals 36 over 5. Right, so that wasn't that bad, but again, it kind of took a long time, right? There is one thing that we can do. Oh, actually, we're not even done yet. Sorry, because we wanted to find the value of x minus 3, right? Not x. So if we wanted to find x minus 3, we plug in x equals 36 over 5, and then we need to find this common denominator, right? So I'll take this 3 and I'll multiply it by 5. So I'll get 3 times 5 over 1 times 5, right? 36 over 5 minus this, which becomes 36 over 5 minus 15 over 5. Or, let's see, 36 minus 15 is going to be 21 over 5. So that's going to be my answer. So again, that kind of took a while, right? Let's see if there's anything we can do to shorten this computation time. So what I'm going to do is notice that this 2x minus 6 can be, like, if you factor out a 2, it can turn into x minus 3, can't it? So if I factor out 2 from 2x minus 6, I'm left with x minus 3, right? And when I factor out that 2, it's just going to go right in front of the parentheses, so 2 times x minus 3. And I still have this 4 out here that I'm multiplying it by, right? So again, this 2 times x minus 3 is the same thing as 2x minus 6, right? If you were to distribute it, you get 2x minus 6. So we're allowed to do that. And then minus 9 equals 3 times x minus 3 plus 12. And now what I can do is, remember that I'm not solving for x here, I'm solving for x minus 3. So what I can do is I can sort of treat x minus 3 as its own, variable or its own term. And I can, add or subtract it to both sides and whatever. Like, I should treat this as like one term, x minus 3. So now what I'll do is I'll first multiply this 4 times 2, right? So 4 times 2 is 8, so I have 8 times x minus 3 minus 9 equals 3 times x minus 3 plus 12. Now what I'll do is, just like before when I would, move all of my x terms to one side, I'm going to move all of my x minus 3 terms to one side. So I'm going to subtract both sides here by 3 times x minus 3. And what I get is, just like if I did, imagine if this was 3x and I subtracted both sides by 3x. Let me rewrite it like this. 8x minus 9 equals 3x plus 12. Just like how I would subtract both sides by 3x and I would get, on the left side 5x minus 9 equals 12, right? I can also do the same thing with x minus 3. I'm subtracting both sides by 3 times x minus 3. On the left side, 8 times x minus 3 minus 3 times x minus 3 becomes 5 times x minus 3, and then minus 9 equals 12, right? Because we got rid of that on the right side. Now I can add both sides, I can add 9 to both sides. I get 5 times x minus 3 equals 21. Divide both sides by 5, and x minus 3 is equal to 21 over 5. So that's going to be my answer. And notice how that was like a little bit less computation than before. In my opinion, it is a little bit simpler, although it might take a little bit of getting used to. But let's look at how we can solve this using Desmos now. Here's what I'll do. Let's put in our answer first, and then let's just view the Desmos solution. So we can see that, we did that correct. And now if we look at the Desmos solution, what you do is you plug in this first equation, this entire thing, into Desmos, right? And you can see that what happens is we get this vertical line again at x is equal to 7.2, right? And remember that we solved for x and we found that x was equal to 21 over 5. 21 over 5 is the same thing as, oh, I'm sorry, let's see, why is that? That's odd. Oh, I'm sorry. Yeah, that's my bad. We didn't find that x was equal to 21 over 5. We found that x minus 3 was equal to 21 over 5. X was equal to 36 over 5. Let me pull that up real quick. Yeah, I got confused. I put in x is equal to 21 over 5, but that's what x minus 3 is equal to. X is actually just equal to 36 over 5, right? That's what we calculated, right? So Desmos actually just calculated that for us. We got that x is equal to 36 over 5, which is the same thing as 7.2, right? And you can see that when we, plot this equation, Desmos gives us this vertical line at 7.2, right? And it's telling us that means that this equation, this entire equation here, would simplify to x equals 7.2. Or, x equals 36 over 5, right? So Desmos found for us that x was equal to 36 over 5. And now if we want to find x minus 3, well, we can just plug in this, x is equal to 36 over 5. And we end up getting that x minus 3 is 4.2, right? Now if we go back here, if we wanted to, we could, and there's like a couple ways that you could approach this. One way is that you could evaluate each one of these, right? So 36 over 5, I can plug that in and I can say, hey, what is 36? I know that I'm looking for 4.2, right? So I plug in 36 over 5 and I get 7.2. Well, hey, that's not correct, right? Then I can plug in 21 over 5. And if I do that, I get 4.2. So that must be my answer, right? Another way is that once you found that x is equal to 7.2, right? Actually, I don't think that way would work. Disregard that, never mind. But yeah, that's how we can solve this equation using both Desmos and algebraically. Yeah, and we'll leave off there for now.